Hello and welcome to mrlebeiko.com's explanation of how to find a multiplier or a rate. I'd also like to welcome my friend Bosco. Bosco, how are you? I'm pretty dang good. How you doing? I'm doing pretty well myself. Are you familiar with these problems, Bosco? No, I'm not very familiar with the problem. Are you familiar with the problem? Bosco, I don't understand a word of what you're saying, so again, I'm going to have to ask you to leave just like I asked Meagle to leave. Alright, that's okay. That's dang okay. I'll leave right now, alright? Yes. Alright, everybody. See you later, Bosco. Bye now. Ooh, that was awkward. Alright, so let's focus on this problem 143. Oh my goodness, the lights just went out on me. The lights, oh, there's sun. I can't believe Bosco or Roscoe or whatever his name is turning off the lights on us. So let's look at 143. It says find an equation of radioactive decay in the form of, so it gives us a little form there, and it says the amount of sample at time t. So if f of 0, so our initial value, that's what they're telling us there, so our initial value is f of 0, which equals 100, and then we know after 5, let's say years, we are at 50. So set up a timeline. I'm going to move the book here so we can just focus on this. So our 0 year, we have 100, and our 5th year, again this is a year, we have 50. So we're talking about, since they tell us, they showed us in the equation km to the t, but I'm going to say it's really f of t, f of t equals a to the b, or a times b to the x power. So remember, this is mommy multiplier right here. So we know that's the multiplier. You might be tempted to say this is a half-life and that this is very simple, but really they want to know the yearly rate of decay, or the consistent rate of decay here. So 1, 2, 3, 4. They should be evenly spaced, mine are not, and that's okay. So write out your equation. Your initial value here is going to be this 100 times b to the x equals, I'll call this y. Now let's plug in the one point we know, which is, we know that in the 5th year this thing equals 50. Divide both sides by 100. We get 1/2. So 1 over 2 equals b to the 5th. Now in order to undo this, put your finger over here. In order to undo this exponent, we're going to take it to the 5th root. Since you multiply exponents, that's going to give us b to the 1st power, or just b, is equal to, and we have to take the 5th root of the other side. So the 5th root of 1/2 is going to be 0.5 to the, again 0.5 to the 1/5 equals 0.87 and some change. Again, 0.87. I'm going to round to the nearest thousandth, so that's 0.871. So 0.871, and that equals our multiplier. Now if they want to know what our annual percent of decay is, then we want to say, we have to focus on this a little differently and think about a muffin. So actually this muffin's decaying, so we had 100%. Now we only have 87.1%. So this little part here is just going to be 100 minus 87.1, which is going to be 12.9%. Alright, thanks very much for joining this lesson. Hope it helps you out. Remember, this is your multiplier. That's your annual rate of decay. Have a good one.